Hello everyone, welcome to All About Analytics. So in previous tutorials we have learned that how to handle missing values through measure of central tendency, right? So in this tutorial we will learn how to handle missing values through measure of central tendency for each class method, right? So let's start it. Okay, let's start it, right? So as you can see, I've already written all the codes. You can I will share this file with you in the description link. You can download this file, right? So I'm explaining you how I performed measure of central tendency for each class. First of all, import all these necessary libraries: NumPy, Pandas, Matplot, and Seaborn. Right. This is my data which I have which I have uploaded in my Google Drive. Right, and from that drive, I have imported this dataset. Okay, and then I imported this dataset path inside this dataset underscore path1 variable, and then converted this dataset path into a data frame called df. Now as you can see, I have printed all these first 5 rows of these dataset df.head, right? pd.set underscore function. This function is for showing all the rows and all those columns. Okay, by passing these arguments: display dot max underscore columns, display dot max underscore rows. None is used for I wanted to print all those columns. If you wanted to print first 5 or 10 rows, so you can replace none through the value through the columns, number of columns you wanted to print, right? Here in missing variable, what I've stored is this is the percentage, that how much percentage of data is missing, right? Then what I performed is, in missing one, I have took the data which data columns names which are having missing values greater than 20 columns, sorry, greater than 20, I have extracted the columns which are having missing values greater than 20%, right? This is stored in missing one. Okay, and now what I did is, next step is, i'm the I dropped all those columns which are having missing values greater than 20. Okay, so and next function, just give me a minute. Okay, I'm audible. Yeah. So in this next function, what I did is, I dropped all those columns which are having greater than 20 missing values, greater than 20% missing values, right? And stored this new data frame inside a deleted underscore call variable, right? Now what I did is numerical. I selected all those numerical columns first. So this is my dataset name: deleted dot underscore call dot select underscore dtypes include which type of variables I want, numerical variables. So definitely I will select int64 and float64 type kind of variables. So I stored all these values inside this column, numerical underscore column, right? Now what I did is, I checked for null values inside the numerical columns. So as you can see, in result what I've got is, loud frontage is having 259 missing values, and garbage air BLT is having 81 missing values, and there is one more column somewhere. If we find, yes, mass VNR area, here it is. Okay, so now what I did is, I took these numerical variables inside a list, as you can see here, load frontage, mass VNR inside a list, and named that list as a numerical column which are having missing values. Okay, you see, and then I printed the values. I printed the places where our columns are having missing values, as you can see here. Through this way, you can print all those missing values, or all those rows which are having missing values inside our particular columns. So as you can see, seventh row is having missing values in lot frontage, and this and so on, right? Now let's move on to next block. Now see this as df.lot config. What I've did is, I have taken out I've selected out some variables. Give me a minute. Lot config, yes. I've taken out filling the. Now what I wanted to do is I wanted to fill these NaN values, right? For filling the NaN values, we must choose some categorical variable. I'm filling these values using a class, right? So for choosing a class, we must choose first a categorical variable. So I selected this categorical variable dot config. As you can see, you can find this in dataset. Just give me a minute, I'll show you this. Where is dot config variable? Mm, this variable is present in this variable is present in our dataset. Lot as name is lot config. LOT75G. Where is it? Yeah, here as you can see, this is lot config, right? Okay, what I did is I used a unique function to get all these classes which are present inside the our lot config column, right? So these are the classes which are present inside lot config column. Inside fr2 corner gold, I don't know what to pronunciate this one, gold sack. Okay, these are the subclasses present in our column, right? Okay, so what I will do is I will impute mean value through this. On lot config, I will impute mean value inside the lot frontage using this categorical variable whose name is lot config. So what I did is I've used function df.log. I wanted all rows of lot config which are having values subclasses. Okay, subclass means inside this class. First class is this now, inside. Okay, so I want all those rows which are having I want all those rows inside lot config which are having value equals to inside, right? And which match with lot frontage. Okay, so what I did is dot I used replace function to replace NaN values. Dot replace np dot nan comma df. I used the same. I just copied the same code over here and dot mean. So what it will do, it will select lot frontage, okay, and select this one lot config and find out inside only those columns which are having inside values, which are matching with inside in lot frontage and lot config. Okay, so in this way you can impute all those missing values. As you can see here, there's all values are imputed, there is no missing value any. Okay, so here what I did is, but this one is open, but what I did is over here is only for one column which was for lot frontage, right? I wanted to now I wanted to perform this for all of the columns. So for doing that, what I did is, here you can see numerical column. I took all those values which are having missing values, all those columns which are having missing numerical columns. First I'm doing this for numerical columns, right? So I took all those numerical columns, these ones, three numerical columns. Okay, then I took categorical variables for the same which can define these columns. Okay, categorical variables which can define these columns. Okay, you can choose here another columns if you wanted to choose, for example mass VNR area, so you can choose mass VNR type, but in this data says mass VNR type is having missing values, so I didn't select that. So I choose this column exterior second, right? For garbage yield I have chosen this kitchen quality. Okay, this selecting columns or subclasses is domain based. For example, in particular domain, if you are having a good knowledge of any domain, so you can perform this function through this, or you can use this technique. Okay, so let's then what I did is For example, for filling the missing values of lot frontage column, I chose lot config. For filling the missing values of mass Vienna area, I chose exterior second categorical variable. For choosing this numerical variables, filling this numerical variables values, I chose this categorical column, right? Then what I did is I used a for loop variable as cat underscore var num underscore var. Okay, declared these variables, and what I did is I zipped these columns, numerical column and categorical column, into one. For example, okay. So what this loop will do is it will took when it will took a categorical variable. First, it will took a categorical variable lot config, then it will took a lot numerical variable, right? Then what this loop will do is it will select a unique class name inside this lot config. For example, if it selected a first variable class at lot config, then it will select out all those unique subclasses present inside it, right? And then it will perform this function. Here what I've did is df. I want all those rows which are present inside the categorical variables and which are having value equal to variable class. What is variable class? A class variable classes present inside these three columns, all those subclasses which are present inside these three columns. And how I will get all these three subcolumns, I will get through this function dot unique. Okay, now what I did is then I use this function numerical underscore, sorry, not this is the function, this is variable name, numerical variable. What we are trying to do is we are trying to fill missing values in numerical underscore variable function, right? So I want all those columns, and then I wanted to replace all those NaN values which are present in my numerical columns, right? So what I did is I just copied all this, and just after that I written dot mean, and has go, you have all the functions are your code is completed for your code is ready for value imputation, right? So now as you can see here, after running this code, I have what I've got: df underscore copy. This is my name. This I have forgot to explain this. What I did is I make a copy of my old data frame and new data frame. This is the copy of, this is the new data frame copy of this one. Okay, df dot copy, and df underscore is copy of df dot copy. Okay, I hope you can understand. And I'm really sorry for my bad English. And as you can see, what after running this code, I have got this df underscore copy. And then what I did is I checked for numerical missing values in numerical columns. So as you can see, here are 0 missing values inside my numerical columns. So through this way you can clean all those numerical values which are having missing values inside them, right? And same you have to perform for categorical variables also. So first of all, I'm showing you the data distribution plot before and after. So here what I've did is plt dot figure. This is my figure size I've done. I've took a variable name I and var, and then enumerated numerical I took all those columns with missing values. Okay, this is my original data set, and this is my updated data set with missing value imputational. Okay, plt dot legend is for plotting these labels, as you can see in the graph. Okay, so let's show you the figure. This is the figure. As you can see here, this is the line in blue one is data without imputation, and line in orange one is data after missing value imputation. So as you can see here, the values have been screened. This means our data set is cleaned in a right manner. Okay, now what I did is I took median values instead of mean value. I replaced the same data set with median. I have same replaced all those missing values with median values also. As you can see, I performed this one in same way. So just what I did is just I have removed mean and in place of mean I have written median. Okay, and then I have plotted all this median also, and as you can see this is the original graph. In blue one I'm getting original, in orange we are getting mean, and in green we are getting median values. Okay, so through this way you can clean your numerical through this way you can clean your data set. Okay, but sometimes what we get is we are uh, we are creating what we are doing sorry we are um, we are cleaning our numerical variables with the help of categorical variables, right? So sometimes what happened is our categorical variables or columns are also having missing values. So in case until our categorical variables are not cleaned, we cannot clean our numerical variables. So first what we have to do is we have to clean our numerical variables first, sorry, categorical variables first. Okay, so here I am showing you how to clean your categorical variables. Read your data set. Okay, I've stored my, see, this is my dataset path. I've stored my dataset path inside file underscore path, and this is converted this into a data frame. And then what I did is data one dot, this is because my data frame's name is data one. So what I did is I selected all those columns which are having string values, object values, right? And then what I did, I find the percentage of values missing. Then I deleted all those columns which are having greater than 20% missing data. So these were the columns which are having missing columns, missing values greater than 20%. Okay, after doing that, I checked out categorical variable dot shape, and this was 38 categorical variables we are having. Okay, now this is the missing values which I these are the columns which are having missing values, right? Okay, then I search for, then what I search for columns which are having missing values greater than 0. Okay, I want their names. Using this keys function will return us names of those columns, and store that column's name in this variable, cat underscore variable, right? Categorical variables. And then what I did is I filled all those missing values using this constant, missing constant. What I did is fill any function. As for filling all those values, I selected first this one, first column mass Vienna type, and then filled, because all those in place of none, all these were none values present. What I did is I replaced these values with missing. Instead of none I write missing, right? So for doing this you have to use dot fill any function. Okay, so as you can see, after doing this, your all those none values will replace by missing, okay. And the second method is, what you can do is you can use mode function also. In case, for example, mode what is mode value? Mode value is the most repeating value inside the data set. For example, if this none is, as you can see, this none is the most repeating value inside my data set. So I find it out, what is the mode of this column, mass Vienna type dot mode. Okay, so in output what I get is none is the most repeating value. So I put this value inside as mode value. So all those NN values will be replaced by this, right? Okay, so as you can see, categorical underscore where mass Vienna type not value underscore counts. So this will count which value is having highest repeating value. So as you can see, I've told you none is the most repeating value here. 864 times it has been repeated, right? After that, what I did is I filled those missing values using the mode function. Same, none was the most repeating value, and I did this. I filled or removed all those NaN values using the mode of this column. But this is only done for only single column, right? So for doing it for all the columns, what you have to do is you have to use a for loop for var cat underscore variable. All those category variables are selected inside this variable, right? Then what I performed is categorical underscore var variable name dot fill any category. Wherever it will find missing value inside this loop, that value is filled by that column's mode value, right? Have you understand that? Okay. And comma n place equal to true. N place equal to true means uh, that value will be replaced in your original dataset also and saved. Okay. And this way you can clean your numeric categorical values columns also. So as you can see now, if you can check your dataset category under where dot is null dot sum, it will show zero missing values, as you can see here, right? It is showing zero missing values. Then what you have to do is you have to plot a histogram plot to check the distribution. So as you can see here, this was the old categorical underscore where this was the old data, and this one is a this one is updated data, and this one is not imputed data. Okay, so as you can see there is a lot much difference in all these columns. Here you can see not imputed column is this. Here you can see here some changes have came. Here in this column some changes have came. Here in this column we have some changes, right? So these are where the columns where after imputation some changes have been came, right? So through this way you can change, you can also impute your categorical variables and numerical variables. In the next tutorial we will discuss and I will code about how we can clean the data through sorry huh, through how we can perform missing value imputation through machine learning algorithms, right? Like using simple imputer, scikit-learn, simple imputer, etc. Okay, so thank you.